Hello students, welcome to my channel. I decided to do a projection of points problems in CAD. So in the previous video I've explained about quadrant system with the help of the reference planes, horizontal reference plane and vertical reference plane. I just brief about it before getting into the first quadrant. So here in the video you can see this is horizontal reference plane which is named as HP, and this is vertical reference plane which is named as VP. So this divides the entire space into four quadrants. The intersection between the horizontal and vertical plane is considered as XY line. So this divides the entire space into four different quadrants which can be seen like this. See, first quadrant, second quadrant, fourth quadrant, third quadrant, and fourth quadrant. So this is first quadrant, this horizontal plane above HP in front of VP. This third quadrant below HP behind VP. So whatever we have towards the right side is considered as in front of VP. Whatever we have to the left side is considered as behind VP. Whatever below horizontal plane is considered as below HP. Whatever is above horizontal plane is considered as above HP. So today I am just briefing about first quadrant. So how do I define the first quadrant? Very simple. First quadrant can be defined as above HP in front of VP. Now let us go for the first quadrant. So yeah, so this is first quadrant. As you can see, I removed the remaining quadrants. We only have horizontal plane, vertical plane, which is in first quadrant. So now we can clearly make out this is horizontal plane, this is vertical plane, and the intersection between those two is XY line. So it is also marked HP and VP. So here you can see a single point which is floating in the middle of nowhere in first quadrant. So how do I define this point? I can define this point as the point is above horizontal plane and in front of vertical plane. Now observe that you are the observer. So as you are seeing, so when you see, it appears to be in front of VP and above HP. Okay, so this is what first quadrant is defined as. Now, so as an observer, when you see from front, okay, you project it, it appears to be on vertical plane. So this is why it is called as front view. Okay, and as an observer, if you see from top, right, you project it on horizontal plane, and hence it is called as top view. So it is this front view and this is top view. Always front view will be denoted as A dash and top view will be denoted as A, and intersection will be having XY line. So for the representation of this in a 2D paper, we considered rotating horizontal plane as 90-degree clockwise. So if I rotate horizontal plane 90-degree clockwise, I'll get both horizontal plane and vertical plane in a single frame. So let me get to that. I'm going to start with a new drawing. I'll just do the basic settings. Usually we'll go with A4 sheet, and we don't want any background right now. So as I've told you, since we are dealing with the first quadrant, so I'll start with an XY line. There's the intersection line. I'll represent X and Y, and above which we have vertical plane, correct? Above which we have vertical plane and below which we have horizontal plane. So let me show you that. See, here you can see this is vertical plane. This is XY line, right? Above the XY line, I have vertical plane. And why did I consider HP below XY line? Because I am tilting HP 90-degree clockwise. So considered both are now parallel to each other. Now instead of considering perpendicular, both are parallel. And XY line differentiate VP and HP. HP is below XY line and VP is above XY line. Now how do I define this point? Say this point is A. How do I define this? For defining, I need a actual measurement. So let us assume now, usually in the problem, they'll give you exact value. Right now, I'm just considering the point A is 40 mm above HP and 50 mm in front of VP. Okay, 40 mm above HP, 50 mm in front of VP. So for example, say if it is front view. Now, I told you 40 mm above HP, correct? 40 mm above HP, I can see with respect to the XY line, it is 40 mm and it is represented as A dash. So where do I get that? Above XY line, above HP, above XY line. Very, very simple. Okay. So front view, above HP, above XY line. Now, I also told it is in front of VP for 50 mm. Okay, 40 mm above HP and in front of VP 50 mm. Correct. Now it is in front of VP 50 mm. Where do I see it? I should see it from the top. If I see it on the top, it appears to be on HP, and HP is below XY line because I'm tilting HP 90-degree clockwise. It comes below XY line. You can also observe if I go to top view, see, this is how it is. Correct. Uh, it is on HP. And how much in front of VP, which will be 50 mm in front of VP and which will be denoted as A. So this we have to represent in a 2D drawing. So HP VP, I'll just go with the projection line. Projection line should be always thin line. So you can pick anywhere here. Since we have only single point, I can pick anywhere in the middle. It is 40 mm in front of VP. Therefore, I'll type 40 length and it should be a vertical reference. So I'll just project it. And exactly at the end of this, 50 mm in front of VP will appears to be below XY line. So I just mark the line. I have to keep the points. In the line itself, I have a point tool. I'll go with this, and the thickness of the point is supposed to be 2 mm. So at the end of this, I'll place the point, and at the end of this, I'll place the point. Now I said 40 mm, so I'll just represent 40 mm. Similarly, I'll just represent 50 mm. So this is front view, therefore it is denoted as A dash, small letter A with dash, and this is top view, therefore it is denoted as A. Now we can also represent using a leader line. Just go with the end of the line. Just extend the leader line. I'll just type this as front view, and I'll just type for this as top view. So this completes the representation or projection of a single point which is situated in first quadrant. So just remember, above HP, above XY line, in front of VP, below XY line. Very, very simple. So this completes the problem. If you like the video, if you are studying CAD, if you are interested in CAD, like and subscribe the channel. Thank you.